Chris from the Great Brick Lab, and this is your weekly update on Big Robot. Today we're going to talk about Teachable Machine. If this is your first time here on any one of these videos, welcome. Thank you for viewing. With me I have Amanda.
Hello.
Hello, Amanda. Amanda is a designer, builder, engineer extraordinaire of Big Robot, the Lego AI-controlled sorting machine. There's a lot of content in the previous 3 weeks of videos. Those are linked in the description of this video. I suggest if you're interested to go and watch those. There's conversations about the machine itself, some AI conversations, lots of really good content there. Today's focus is going to be on Teachable Machine. So I'm going to kind of go over who we are, what we're doing, and why we're doing it. Again, I'm Chris from the Great Brick Lab. I run a Lego store, or I own a Lego store, and I work there sometimes. It's really a great pleasure to have a Lego store on Bricklink and Brickall and have an abundance of parts that we have a great desire to sort. Amanda is a high school student, very, very intelligent. She's been in a lot of robotics challenges, and she has volunteered her summer to build a Big Robot, what we've called Big Robot. We're planning on changing that name at some point in time. Haven't quite decided that yet. But she is building a robot and being funded by the Great Brick Lab. There is also an opportunity for you to give if you're interested in giving. In the description, there's a Give, Send, Go, and I can actually put a banner up. Let me put the banner up. There we go. The banner has a Give, Send, Go Lego/Lego AI. Any funds that are given to that are going to be paid, are going to pay for this project to become an open source project given to the entire world. Whatever we develop, whatever the results are of this, our goal is to help the world sort its Lego. And that is kind of what we're doing. At the end of this 14-week or so, 12-week, 14-week project, we hope to have a functional machine, and these weekly updates kind of keep you apprised of what we're doing and how we're doing it. So welcome those of you in the live stream, Andrew, BrickQuest, Will Harper. Thank you so much for joining. If you do have questions, we can see that. We would love to talk with you or just give you some feedback on what we're doing. So let's do this. Let's give a quick update because Amanda has been busy with the building. Materials have been getting delivered quite regularly. And I'm interested, Amanda, tell us what has happened in the past week.
All right, so this week I finished the second part of the robot, that carousel mechanism that wasn't done at the last update. So you can see that here. I don't know if I'm showing it very well. But this has a new sweeper that I designed. All of the parts for that are 3D printed, and you can actually adjust the angle on it. So the way that works is the parts go onto the carousel and they spin around and then they come off. I'm having trouble showing this, sorry. Can I switch my
camera? Go ahead, switch your camera view, that'd be great.
That would help me out a lot. Facing back, okay, sorry.
All right.
Okay, that's much better. So I can actually get a piece. There you go. Here. For those of you who have not seen the video that Chris posted, it's just a short. It shows how the parts go around the carousel. And then when they collide with that white piece in the middle, and they're supposed to, well, this is actually supposed to spin a lot faster than I can make it spin by hand, so the parts fly out to the edge. But if they're in the right spot, then they'll ride across that and fall onto the conveyor belt. So this week I actually, if I remember right, last week the conveyor belt was not fully assembled.
There was no cleats and it wasn't painted, so I see those changes.
Yeah, so I ended up 3D printing the cleats. They I came up with a more optimized design that's very simple. It's just a small strip, and I found that super glued onto the PETG plastic worked just fine to mount it onto the canvas side. One thing we did have to do to get that glue to all stick was we had to clean the belt with isopropyl alcohol every couple of inches here because it was a treadmill belt, so it was really dirty. So that way we could glue all of these on. And then I just used regular acrylic paint, and it seems to be sticking just fine. But the other thing that I did yesterday is I took this whole assembly apart, and, well, not completely, I just took the one side off, this side, and I put all the screws into these plates at the end that mount the shaft, so that I could adjust them outwards and get it to get the belt completely tensioned. So last week I was having a problem where if you looked underneath of the belt, it was really, really sagging under the table. But now you can see all the way through to the other side. So that's a tight belt. So I used some elbow grease there to get that tight.
Yep.
And
okay.
yeah, today I finally got the spinner to connect to the conveyor belt as well. So things are coming together.
All right. That's great. I love the look on that belt. It looks really actually quite great. So as Amanda has been describing this, so I think she must be having a connection problem. We'll get her connected again in a minute. The progress on this is all throughout every video. So if you want to participate and help us out with this, I encourage you to click on that Discord link inside the description and bring your participation. We have some needs. We have, I'd like to get this a little bit more promoted either to other Lego stores or other individuals. It looks like she's coming back in here. So we'll see her come in just a minute. And then I'd also like some help with the management of the team. We have some great individuals who are participating on the AI side and the Teachable machine, and that is where I'm going to be giving an update today. All right, welcome back.
Hi, sorry, I
okay.
accidentally exited.
Yeah, I hit that button all the time, so we're good. So anything else you wanted to give up on updates this week for what you've accomplished?
So for me, the last thing I was going to mention was yesterday we actually, we got the carousel and the conveyor, both of the motors running. I just temporarily plugged them into one of the hubs that we use for our robotics team, one of the robot controller hubs.
Okay.
In case the robotics team wants to use it. But so for the circuit board right now, we actually ran into a challenge with that because the components are so small. It's hard to handle them and keep them from just like falling off of the solder pads. So my brother, who is mainly working on that electronics part, he is going to the University of Illinois, so he learned about soldering in his electronics class. And there's a cool thing with like a heat gun that just heats up the air. So you don't have to touch the part with a soldering iron. It just heats up the air around it to melt the solder and connect the part onto a solder pad. So you just place the part where you want it, heat up the air, and solder it on. So they have this kind of tool at the university, but we didn't have one at home. So we had to try to find a cost-effective one that we could get for this project. And hopefully that comes by like next week, and that should make it so that it's a lot faster to build the circuit boards.
Okay, great. Very, very. I just appreciate your knowledge and your brother's help, especially. This wouldn't be happening without you guys. So thank you so much.
Yep.
So this
Thank
coming
you.
week, do you have any more assembling that you need to do? We were talking right before the stream started. You said that you're pretty close to having it fully assembled.
Yeah, I went to do some more testing with the robotics team, electronic hub, and route some wires to that. Other than that, I mostly have I have some gaps to fill, like the carousel. I had a strip of sheet metal that goes around the back of it, and it didn't fully seal. One thing you'll notice if you look at what I have here, I used some Super 77 and glued felt all the way around the outside of the carousel, but onto that sheet metal piece, and that way when the spinner spins around, it doesn't just grind against the sheet metal and make a lot of noise and like wear down the plastic of this plate. So I might have to do that some more in some different places, because I have a little bit of an air gap back here. I don't know if you can actually
Yeah, I can
see.
see a little bit of light going through there. Yeah.
But when I was testing it yesterday, we had some pieces fall on the table, and that was kind of sad. So I need to seal everything up a little more.
Yeah, this is for building a prototype machine. Just you and your brother and all the manufacturing, all the processes you guys done. It's actually quite impressive. That's just a little bit. Yeah, well, and it is a prototype machine, so I don't expect it to fully function 100%, and we're going to have rebuilds. As much as we learn about how to do this right, we're also going to learn about what doesn't work as well. And just this past week, another group of students had posted a video on YouTube about a project that they did, and they also had some lessons learned that they became quite valuable that I think we can gain some knowledge from too.
Yeah, I did. I noticed that on one of the robots that you shared on the Discord that another common feature that they have is the conveyor belt that comes before the vibrating channel.
Mm-hmm.
Now, I think that kind of makes sense just to limit the number of parts that are piled onto the channel.
Mm-hmm.
For the size of channel that I have, I'm not sure if it's that big of a problem, but we'll see when we get to having like full bins of parts.
I think we could probably build something pretty simple from what they had. I don't know what it was built out of, but I don't think that they spent a lot of money on that. It was a pretty low end thing.
Yeah, the one that they had online was really small compared to what I've built. It's hard to build something this size without just like instantly spending $1,000 or $500 or anything.
Yeah.
I know with our first Tech Challenge robots, we can build a lot of them for relatively cheap because they're just so small. So this was kind of an interesting experience for me because it's just such a giant robot.
Yeah.
But it's got to process a lot of material, so it kind of benefits from having all this space in it.
Okay. All right. So if you're ready, I would like to transition into tonight's topic of choice for Teachable Machine, unless you have anything else you wanted to say first.
No, I'm good.
Okay.
Go ahead.
So what I'm going to do is I'm going to share my screen. And let's do, here we go. Okay. So what you can see here is a model that I had help from Andrew Hammond, who's in the chat right now. So thank you so much, Andrew, for doing the work on this. He's taken about 200 and I've got 500 photos. I can't remember the exact number of photos, but I loaded photos based on the following categories: modified plates, slopes, tiles, and bricks. And then I added one to the model called minifig bits, and I've actually taken about 25 images. It seems to take double image every time you take a picture. And what I have on my setup here, let me show if I can show it a little bit. I basically have a plate, a paper plate right here with a ring cam above it and a webcam just above that. Really super simple, nothing complicated there at all. And we're trying to figure out a model that if you wanted to participate and contribute to the data set that we're collecting, then you would be able to simply set up something. And Andrew's kind of in charge of that right now. And we'll eventually learn what works, what doesn't work, and how to build that data set and on that models. So what I'm going to do on Teachable Machine based on these models is I'm just going to start throwing some things on the paper plate and see what it identifies it as. So here's the part right here that I'm going to do right now. This is a little round, and it's actually an assembly. So there's two pieces there, but that's exactly what could happen. I just dropped it on there, and we'll see what it identifies it as. So it looks like it's identified it as minifig bits, and that's, but like I said, the data set's pretty small. So let's put something else up on there. So I've got a 2x4 plate right here. And it's landed on the slope. Okay, so obviously the data set for that is not very good, but what I can come into here is I can come into the webcam, and I can, let's see, I think I have to turn off my input here. And then if I hit hold to record, so I've added that plate to the model here. So now I'd have to hit train model, and that's actually kind of risky because my training has been taking forever. So maybe I shouldn't have done that. But that's exactly how you would do it. If you're building your own model for your own machine, and depending on your setup. Now, the backgrounds of these images are quite important, the consistency of it. So talk to me a little while this is building that training model, which actually could take longer than the stream. I shouldn't have clicked on that button, but maybe we'll wait it out. Talk to me, Amanda, about the background that we're going to have.
Yeah, okay, so the background with the cleats is going to just be rolling straight lines on a white background. So, my suspicion is that you can probably teach Teachable Machine to have another category that is called background, and you just take a video of the belt going through.
Mm.
I saw somewhere that you could have a background class, or you could train it on the background or something. But it won't be just clean white because it has to have those cleats on it.
Right. So we don't have the webcam set up yet. Do you think by the next live we do next week, there's any bit of a possibility that we'll have that webcam, or is it too early yet?
Oh, I can definitely get it. I was working on a new design today, and I can probably cut out some parts for it tomorrow. And over the weekend, I should be able to get a lot done. Hopefully.
Yeah, so there's a comment here from Andrew. Thank you, Andrew. It says that we can do some image processing to make the backgrounds less of a problem. I think in the Discord, he was talking about a script that he had written that can take and focus just on the image, the difference between the white. Is it? I think it's a matter of being the difference between the background and the actual element itself. So if the background is less of a concern, then I really have to have a large data set of photos that we can just get from anywhere. But the part itself could land in a number of different directions and being identified. So the data set is going to be quite valuable. I really want to be able to build the data set through crowdsource information. But there's a certain psychology behind opening it up to the world of building this data set. Not everybody is going to be a good actor. There's actually some bad actors out there. And if we gave everybody the ability to contribute to the data set, some people will by intention come in to ruin the data set or mess with the accuracy of the data set. So it will be a controlled group of individuals who are vested or want this to be successful that will be coming in to help us build the data set. and there'll be some qualifications that you'll need to kind of get some gates you'll need to get through to say, yes, I can contribute to the data set. That'll be through the Discord. So if you want to contribute to the data set and then get access to the data set afterwards, we would love to have the help on doing that. We need a ton of photos, and we do have a PDF, or I think there's a document inside the Discord that shows. I might as well go to that document since we're waiting for this data set to build. That document does describe the different categories here. So just give me 1 second. I'm going to find that in the AI. No, it's under sorting methods, correct? Yeah, it must be under AI because I don't see it here.
It's under AI.
Thank you. Okay. I think I have it. Okay. So here is, it's really, really small text, and I'm not able to zoom in on that. So there's the different categories here, but let me open up a different screen here. And I am definitely stalling when that model's rebuilding. Let me open up a different screen here. There's a Google Doc. Okay, so if I do, there we go. So here's examples of the first category, bricks, and then rounds, Technic bricks. So the pins and the holes and the hollow tops of these things should be identified. These categories are actually very much to do with how an AI thinks, not a person thinks, because a person would easily say that brick and that brick could go in the same category. Easily say that because there's so much commonalities or common qualities, features to those things. Then there's another category here for plates, and it looks like round plates, wedges, cut plates, Technic plates, so plates with holes, pins, modified plates, or any other kind of the hinges, joints, jumpers. This is all designed on what we think the AI would be able to recognize through a strong data set. Tiles, things that don't have studs on, snots that don't have studs on top, dishes, and then I guess there's another category here for snot. I don't know. I thought snot was studs not on top. I must.
No, yeah, studs not on top because it's like studs at 90-degree angles or studs on the bottoms.
Oh, that's what's not. So tiles are tiles and snots are studs not on top. So there's studs on the side.
Yep.
Well, there you go. I can sell Lego all day long, but I didn't know what a snot was until right now. All right. So there's the data set that we're going off of, and that's all this information is right inside of our Discord. So yeah, I regret clicking on that. We're 23 minutes into this, and I've got my model not working. So here's a comment from Andrew. It says the data set will be open source and available to the community, so contributing will be helpful for everyone. And really, when it comes to what we want to give to everybody at the end, the AI is one of the most powerful things. I don't believe necessarily that we're going to give away the design that Amanda has used, the CAD design. That will be given away and made available as well. However, the likelihood of somebody actually going with that exact same design, you can see the manufacturing process has been quite intense, and she's got a lot of equipment to help her be successful in building that machine. Not likely that many people are going to have that. So a model that is more friendly and uses Lego more likely will be something that we'll have to come to eventually. And I don't know if this group will do that or if a different group will come in and use our data set and the Python code that we get out of it to do all that. I don't know why this takes so long. This is kind of frustrating right now.
Yeah, probably should have put more extra images in there.
Instead of just one.
Get some more bang for your buck.
Yeah, I'm not sure how this builds its model, but I can tell you right now that every time I've clicked on this, I've actually walked away and came back, and it's redone it. So changes to this model, I will have to learn about what It does in the background to figure out how to make it so it doesn't run so slow. Maybe it's my computer, maybe my internet connection. I'm not 100% sure why that runs slow like that. But I'd love to be able to put more things on there. So I had all of these parts ready to be identified. I got bricks, I got all these things. Some of them it was quite successful on, some of them it wasn't successful at all on. So the data set's just not ready for this. Tell you what, I'm not going to hang out and wait for this. Is there any other updates that we need to give tonight?
I haven't got anything right now.
Yeah, I'm running out of stuff too. So, okay, cool. So I will do this. I will record a video of this data model working and then share that on the channel here. And it won't be via a live format. But I think that you've seen enough to be able to kind of get the idea, and then the content that I'll share coming up here in this week will contribute and show you the data modeling. And if you want to contribute, get on that Discord, help us with this building of this data model. We are going to need a lot of help building the data model. If you have ideas about how to do it more efficiently and quickly, that would be wonderful. But this data set is going to be given away for free. We just have to figure out a way to store all the photos. I don't know how much free space we're going to be able to get out of an account, or if we create an account called Lego AI, I don't know yet. There's ways to give this away for free, and we're trying to figure all that out. So we'd love ideas on that too. Well, it still hasn't built the model, so I'm going to just go ahead and say I think we've got a good update for today. Thank you, Amanda, for participating, for joining tonight.
Thank you for having me.
Yeah, it's great. It's always great to hear from you and updates on Fridays. I look forward to it every Friday because you always make so much progress on that robot. So it's looking cool. If you do want to see any of the robot parts moving, Amanda has created some demonstration videos of the belt and the turntable moving. Just click back to the channel and find some of that content. It's all there. Most of them are only about 15, maybe 30 seconds long on some of the shorts. Those are really quick and easy to see, and you can see how things are coming along. And I'm really looking forward to the next couple of weeks here. This is week 4, and officially I'm saying 12 weeks, but we do get a couple of extra weeks if we need them. So we'll see where we end up in 12 weeks on a completed robot. So again, this is Chris from the Great Brick Lab, and I have Amanda with me here, our resident engineer extraordinaire. So thank you so much. Have a good night, everybody.